If you've ever smoked or vaped or cut metal in a room where there's a smoke alarm, then the smoke alarm would probably trigger itself. So in this video, I will show you how to make a device that will remove power from the smoke alarm for a set amount of time. Before anything, let's first understand how the smoke alarm works. The smoke alarm contains a white wire for neutral, a black wire for live, and a yellow wire for communication, which will be connected internally to live when it detects smoke. And lastly, the 9-volt battery is there for power backup in case if there is a blackout. To switch the smoke alarm electrically, we're going to use the MOC306X, which is a 6-pin solid-state relay. Then to switch the 9-volt battery, we're going to use a NPN transistor. Before using any part, like the solid-state relay, it's important to test it. Time to build the circuit. All done and ready to move on. For the brains, we're going to use a Arduino Xiao, which is a 14-pin microcontroller. For the inputs, we're going to use 2 capacitive buttons. And for the display, we're going to use a blue OLED display. After writing 242 lines of code, there's one thing left to do, to set the delay. You'd probably think that setting it to 1 second would be okay, but if you take in consideration that each line of code takes up a bit of time, then you'd understand that the delay has to be a little bit shorter than a second. So to know what to set the delay to, we're gonna do a short test by setting the timer to 5 minutes, then to start a stopwatch, and after the timer reaches 0, to stop the stopwatch and see the time difference. In this case, it's 9 seconds. Then, after a couple of tries, eventually we got it perfect. I mean, literally perfect. For the power supply, we're gonna use a 5-volt USB power supply. Then we're gonna modify it to make it smaller. This has a half-bridge configuration, so we're gonna remove the single diode and the capacitor, and then connect it when it's off the board. Now to keep it from shorting out to any other components, we're gonna seal it with some electric tape. After that's done, it's time to test it out. And it works. The output is 5.1 volts. Now after finishing all the parts, it was time to print a box and a cover which will house all the electronics. After the print was complete, it's time to remove the supports. The capacitive button has 3 terminals, one ground, one 5 volts, and one for signal. We're gonna connect one wire to each pin. To the OLED display will be connected a black wire to the ground, a red wire to 5 volts, a white wire to SCL, and a green wire to SDA. Now it's time to secure the capacitive buttons with double-sided tape. To give it extra strength, we're gonna pour some UV cured epoxy and then cure it with UV light. Time to secure the OLED display with some UV cured epoxy and then cure it with UV light. To connect the device to the smoke alarm, we're gonna use a 8 conductor wire. Time to wire it up. To indicate where the capacitive button is located and what button it is, we're gonna use a label printer. Before closing up the box, we're gonna test it with a light bulb. Just imagine the light bulb is the smoke alarm. In order to be able to screw the cover to the box, we're gonna insert some brass nut insertions. At this point, we pack in all the components and all the wires and then cover it with the cover and then screw it shut. The battery will provide backup power when there is a blackout, so we're gonna connect a connector which will connect to the shut-off timer. Time to screw it to the wall. In order to keep the wire in place, we're gonna bang in some cable staples. We're up to the point that we have to drill a hole in order to be able to feed through the wire. Last step is to connect the cable to the smoke alarm and then connect it to the ceiling. If you like this video, then please consider subscribing and hit the notification bell in order not to miss any of my new videos.